Hello my peeps, this Algebra Nation video will cover workbook page 49, problem number 6.
I first look at this diagram, I'm thinking, I do not want to do a geometry problem. Is this a geometry problem? No, we can solve this thing with algebra. So we've got this diagram, and what it looks like is one big triangle, and it has a smaller triangle in it. Now, we see that we've got a whole bunch of different points, so that's good. We've got a bunch of different values giving us the lengths of some of those segments. So we want to know, what is the length of the line segment EC? Well, where is EC? EC is the line segment between points E and C. So instead of saying EC, let's just call that X. Let's call the length of EC X. Okay, so that makes things a little bit easier. So when we're looking at this diagram, thinking, all right, we've got a really big triangle, and then this line here, what is this line doing? What is DE doing? Well, DE is just making a smaller triangle within that bigger triangle. So what this really is two different triangles. Let's start by drawing out those two different triangles. So let us keep our values and our lengths of the edges a little bit more organized. So our first triangle, let's make this our little triangle. Our little triangle has A on the top, right? A is our point on the top. E is down here, and D is right here. So what is the length of DA? Do we know that? No, we might not even have to figure that out. What about AE? Do we know what that length is? Yeah, we're told that the length of AE is equal to 10. Okay, do we know the length of DE? Yes, DE, the length is equal to 4. All right, now let's draw our big triangle. Our big triangle, it is a similar triangle. Similar means what? Proportional, right? These two triangles are going to be proportional to each other. So let's see what we've got. Our upper point is A, the bottom of our triangle is C, and then the bottom left is B. Do we know the length of AB? No, we don't need it. Do we know the length of AC? Well, the length of AC, what is the length from A all the way down to C? Well, if we know that this is 10 and this is X, well then what's the total length? 10 plus X. Okay, so the length of AC is 10 plus X. What else do we know? Do we know the length of BC? Yeah, the length of BC is 6. Okay, well we've got these two similar triangles. What are we trying to figure out? We want to figure out the length of the line segment EC, where EC is just what we're calling X. So we need to solve for X. So what can we do to get that value? Well, we're going to set up an algebraic proportion. Say, okay, for our little triangle, we can look at the ratio of the height to the base as 10 over 4. Well, since they're similar triangles, it's just a scaled down version of this triangle right here. It's going to be proportional. The proportion here of your height to your base has got to be the same proportion over here of your height to your base. So 10 over 4 needs to be equivalent to 10 plus X, since that's the height of our bigger triangle, over the base of our bigger triangle, 6. Well, now do we do? Well, we're just going to solve for X. So what do we need to do? We're going to cross multiply. So I'm going to multiply my 10 times my...
I thought she said we were going to take a brain break. In case you missed the sports news this weekend, Friday night, how sweet it was.
Another one bites the dust, and another one gone, and another one gone. Another one bites the dust, hey, I'm gonna get you too. Another one bites the dust. I think another get.
6. Remember, that's the same thing as saying I'm multiplying by 6 and I'm multiplying by 6, right? If I multiply this side by 6, that gets rid of my 6 here, and whatever I do to one side, I have to do to the other. That's what that's doing right there. So we get 6 times 10. 6 times 10 is equal to 60. All right, now what? Now we got to do our other side. We have a 10 divided by 4, so what are we going to do? We're going to multiply by 4. We're cross-multiplying. Now, am I multiplying my 4 times 10 and then adding X? No, I am multiplying this entire quantity by 4. I'm saying 4 times 10 plus x. What do I see here?
Ah, it's too bad you didn't say distributive property. Otherwise, you would have got plus 10, but I said it first.
Parentheses. Whenever I see parentheses, I need to distribute, trying to get rid of that. So whatever we distribute, we need to distribute our outside term to each term within your parentheses. So distribute means multiply. So I'm going to take my 4 and distribute it to my 10. 4 times 10 gives me 40. Now what? Well, I have a 4 and I have a positive x. 4 times x gives me a plus 4x. Okay, I'm getting closer now. Remember, I'm ultimately trying to figure out what my value of x is. So let's see what we get. 60 is equal to 40 plus 4x. Well, if I'm trying to solve for x, I want to get rid of this 40. So I'm going to subtract 40 from both sides. And that gives me 20 is equal to 4x. Well, am I done? No, we need to solve for x. So we're going to divide both sides by 4 so we can get x by itself. And we end up with 5 is equal to x, because 20 divided by 4 is equal to 5. 4x divided by 4 is just equal to x. So we've got our answer. Our value of EC, the length of the line segment EC, which is what we called x, is equal to 5. Let's see what that is doing in our picture. It's saying that this length EC is equal to 5. Remember when we set up our proportions? Originally we said, you know what? The ratio of your length to your base, your height to your base for your little one, 10 over 4, needs to be the same as the ratio as your height to your base for your bigger triangle. Well, if our height here is 10 plus x, 10 plus 5 would be 15 over what? Over 6. Let's see if those are equivalent. How can we reduce 10 over 4? What number goes into both of those? 2, right? So 10 divided by 2, we get 5. 4 divided by 2, we get 2. All we did was simplify the side of our fraction. Now let's simplify the other side. 15 divided by 6, what number goes into both of those? 3. So if I divide my top and my bottom by 3, 15 divided by 3 gives me 5. 6 divided by 3 gives me 2. They are proportional. Remember, we have these similar triangles. We have two triangles that are proportional. Your smaller one is just a scaled down version. So we set up our algebraic proportions and we solved for our line segment, which was x equals 5, and then we checked our answer by making sure that our two triangles were actually proportional. So if you guys have any questions on this one, just let me know. Post on the wall.